It is the 3rd of November 1942, and somewhere in the darkness of Bordeaux harbor, a man is dying by degrees. The water is 11 degrees Celsius. He has been in it for nearly 40 minutes, moving inch by inch along the underside of a German tanker, pressing his body flat against the hull to avoid the sweep of the searchlight above. In his hands, wrapped in a waterproof canvas satchel, he carries 6 devices that look, to any casual observer, like nothing more than pieces of scrap metal, flat, roughly rectangular, curved slightly on one face, rusted at the edges, weighing approximately 2.5 kilograms each. They have no obvious trigger mechanism, no timer, no wires trailing behind them. They look, frankly, like the kind of thing you might find rusting in a garden shed. He is Corporal William Sparks of the Royal Marines, one of the men who will later be celebrated in the film Cockleshell Heroes. The operation he is part of, codenamed Frankton, has already cost the lives of 8 of his colleagues. He attaches one device to the hull of the tanker, pressing its magnetic face hard against the steel. He feels it grip. He moves on to the next ship. What Sparks is placing against those hulls is the limpet mine, and the fact that it looks like scrap metal is not accidental. It is, in fact, the entire point. The limpet mine is one of the most elegantly conceived weapons ever produced by British ingenuity under pressure. It was designed not to impress, not to intimidate in the open field, but to function in secret, in darkness, at the hands of a single person, against a target that might be worth 100 conventional bombing raids. Its genius was not firepower. Its genius was invisibility. And in the years between 1940 and 1945, devices like it, carried in coat pockets, strapped to bicycles, tucked into workers' overalls, would contribute to the disruption of the German war machine in ways that conventional military operations simply could not replicate. This is the story of how a department of eccentrics, scientists, and saboteurs working out of a series of requisitioned country houses designed a family of weapons that looked like rubbish and functioned like precision instruments, and how those weapons quietly dismantled the arteries of Nazi Europe. To understand why the limpet mine and its companions mattered, you need to understand the position Britain found itself in during the summer of 1940. France had fallen. The British Expeditionary Force had been evacuated from Dunkirk, leaving behind most of its heavy equipment. The Royal Air Force had held off the Luftwaffe, but the bombing campaign over occupied Europe was in its infancy, wildly inaccurate and consuming aircraft and crews at a catastrophic rate. A single factory in France, producing components for the Panzer program, might require hundreds of bomber sorties to damage meaningfully. And even then, the Germans proved adept at dispersing production and rebuilding within weeks. The problem was scale. Germany controlled a continent. Its supply lines stretched from the Norwegian fjords to the Greek islands, from the Atlantic coast to the outskirts of Moscow. Fuel moved by rail and tanker, machinery moved by canal and road, raw materials moved by ship. And at every node in that network sat a human being, a worker, a guard, a train driver, who could, in theory, be recruited, supplied, and directed to cause precisely targeted damage. The Special Operations Executive, established by Churchill in July 1940 with the now famous instruction to set Europe ablaze, was the organization charged with doing exactly that. But there was an immediate and serious problem. You cannot set Europe ablaze without fire. You cannot ask a French railway worker to sabotage a locomotive without giving him the means to do it safely, effectively, and without obvious evidence of interference. You cannot send a Norwegian fisherman to destroy a fuel depot without a weapon he can carry under his coat, use without training, and deploy without a degree in chemistry. What the SOE needed, in other words, was not a better bomb. It was a better kind of sabotage tool entirely. Something reliable, something portable, something that could be mass-produced in the tens of thousands and dropped into occupied territories by parachute, something that an amateur could use. Existing options were deeply inadequate. Standard military explosives required trained engineers to set. Timing fuses were unreliable and often failed in cold or wet conditions. Commercial detonators were sensitive to the point of being suicidal to handle, and none of these things could be disguised as anything other than what they were. Carrying a standard military fuse through a German checkpoint was not a survivable experience. The gap between what was available and what was needed was enormous. Bridging it would require invention from scratch, but the Frankton raid represents only the visible tip of an enormous program. Across Norway, French railway workers carried smaller companion devices. The SOE's incendiary, known as the incendiary suitcase, and the time delay explosive pencil in its standalone form, and placed them against locomotive fireboxes, fuel lines, and transformer housings. In the Netherlands, dock workers disrupted canal barge traffic. In Yugoslavia, Tito's partisans used British-supplied explosive devices against railway lines servicing the German occupation. Exact records of many of these operations remain either classified or simply unrecorded, the nature of covert operations being that success leaves fewer traces than failure. What is documented is the psychological effect. German security forces, encountering damage with no obvious cause and no perpetrators, were compelled to assume that sabotage networks were larger and more capable than they actually were. Resources were diverted to guard duties that might otherwise have served the front. The cost of maintaining the occupation, in terms of manpower and administrative attention, increased in proportion to the threat that could never be fully located or neutralized. If you are finding this interesting, a quick subscribe helps more than you know. The Germans were unnerved particularly by the invisibility of the method. A bombed factory can be identified from an aircraft and its destruction attributed to the enemy. A limpet mine on a ship hull, timed to detonate in open water, leaves wreckage that looks remarkably like a mine strike or structural failure. The attribution problem was, from the SOE's perspective, a feature rather than a bug. It is worth pausing to consider what the Germans and their allies were producing in the same field, partly because comparison illuminates the distinctive approach of the British program, and partly because the contrast is more striking than is commonly acknowledged. German sabotage capability in the same period was not negligible. The Abwehr ran its own networks of agents and did develop sabotage devices, including time-delay incendiaries used against Allied shipping and industrial targets in neutral countries. However, German sabotage doctrine was in certain respects more conservative than the British approach, favoring larger, more complex devices that required more specialized training to deploy. The German S-mine and Schuh-mine, battlefield weapons rather than sabotage tools, were sophisticated by any standard, but they required emplacement by trained engineers and served a fundamentally different tactical purpose. The American OSS, the Office of Strategic Services, which would eventually become the CIA, worked closely with the SOE and drew heavily on British designs. The OSS Limpet mine, deployed in the Pacific Theater, was essentially a direct derivative of the British design, adapted for tropical operating conditions by substituting certain alloys susceptible to saltwater corrosion. American production capacity was vastly greater than the British, and by 1944 the United States was manufacturing equivalents of many SOE devices in quantities that dwarfed the original British output. What the Americans had in production capacity, however, the British had provided in conceptual originality. The Italian Navy, it should be noted, pioneered the manned torpedo, the maiale, or pig, which was in certain respects a more ambitious approach to the same problem. Italian frogmen sitting astride slow-running torpedoes had succeeded in attaching limpet-type charges to British warships in Alexandria Harbour as early as December 1941. The British were aware of this and drew lessons from it in the development of their own underwater delivery systems, including the X-craft midget submarines used later in the war. The two programs represent parallel but distinct approaches. the Italian emphasis on highly trained specialist operators delivering large charges against capital ships, the British emphasis on simplicity, mass production, and the use of agents with minimal training against supply infrastructure. The divergence matters because it reflects different strategic theories. The Italian and German approach assumed that spectacular strikes against military targets would have a direct military effect. The British approach, developed through painful experience of what air power could and could not achieve, rested on the less glamorous but ultimately more devastating logic that a war machine running low on fuel, parts, and supplies collapses under its own weight. Assessing the actual impact of the Limpet mine and the broader SOE sabotage program is difficult, because the nature of supply chain disruption is cumulative and distributed rather than dramatic and singular. No single Limpet detonation ended the war. What the program did was impose a persistent, low-level friction on German logistics that compounded over time. The most carefully documented case is probably the Norwegian heavy water program. The sabotage of the Vemork hydroelectric plant in February 1943, carried out by Norwegian commandos trained and supplied by the SOE using conventional plastic explosive rather than limpet mines, but employing the same philosophy of small-team precision over mass bombardment, set back the German nuclear program by an estimated 18 months. The subsequent sinking of the Ferry Hydro in February 1944, using time delay charges planted in the bilge, destroyed the last significant consignment of heavy water that Germany would ever possess. The combined effect of these operations, according to most nuclear historians, was decisive in preventing Germany from developing an operational nuclear reactor before the end of the war. The Bordeaux operations, taken together with similar attacks on French Atlantic ports, contributed to what German naval records describe as a persistent atmosphere of uncertainty that required the redeployment of security resources and complicated the scheduling of blockade runner traffic for the remainder of the occupation. In terms of legacy, the design principles of the Limpet mine, magnetic attachment, time delay acid fuse, plastic explosive charge, remained standard in naval sabotage devices for decades after the war. The SOE's pencil time delay fuse was still in use by special forces in various forms into the 1970s. Examples of original SOE devices can be seen today at the Imperial War Museum in London, at the Special Forces Club in Knightsbridge, and at the Churchill War Rooms beneath Whitehall. Several examples are also held at the Welwyn Hatfield Museum, near the site of the original Station 9 facility. Return for a moment to that harbor in Bordeaux. The water is cold. The searchlight sweeps in long arcs across the surface. Corporal Sparks, his fingers numbed and slow, presses the last of his charges against the hull and feels the magnet's grip. He cannot know whether the device will function. He cannot know whether the acid in the pencil fuse has been adequately protected from the water. He cannot know whether the color-coded wire is the one he was told it was. He trusts, in the darkness and the cold, the invisible work of the engineers at Welwyn, the former fairground designer, the chemist who tested his fuses in a bathtub, the women in the production facility who assembled the detonators by hand under magnifying glasses. He paddles away. He has done his part. The charges detonate some hours later. The ships, or most of them, are damaged. The port is disrupted. And somewhere in the vast apparatus of German logistics, a spreadsheet that no one will ever see registers a delay. A fuel shipment is postponed. A repair part does not arrive. A convoy is rescheduled. A front, somewhere to the east, receives slightly less of what it needed. A German tank commander, running low on fuel outside Stalingrad or on the approaches to Kursk, does not immediately connect his situation to a piece of curved metal pressed against a ship hull in the Gironde estuary by a cold and frightened marine. He would be right not to. The connection is too indirect, too diffuse, too characteristic of the way this kind of war is actually won, not in the flash of a single detonation, but in the slow, invisible accumulation of small disruptions, each one trivial in isolation, devastating in aggregate. The limpet mine weighed 2.5 kilograms. It cost 4 shillings and 6pence to make. It looked like scrap metal. It was placed by a single person in a canoe, in the dark, in enemy-occupied territory at the risk of his life. And it worked. That, in the end, is what British ingenuity under pressure actually looks like. Not the great machine, not the thunderous raid, not the weapon that announces itself, but the small thing, the invisible thing, the thing that looks like junk and quietly, methodically breaks the machinery of an empire.